So again, happy Tuesday. Yes, it is Tuesday. Yes, that is Kobe on the screen. Somebody asked because it has been a year since we lost Kobe. Can't believe it's been a year. I think we all know where we were when we heard the news last year. Yes, time does fly. It's crazy, especially this past year. Time is weird this past year. It's flying, but it took forever. Seems like 5 years, 2020, but then 2020 also seemed like it went like that. It's just 2020 was the weirdest year I've ever experienced, and I think a lot of people have ever experienced. All right, so let's go to the warm-up. Let's see. Oh, here it is. Oh, my screen went black. Hold on. Technical difficulties. Please stand by. There we go. There it is. All right, so these are the 6 points, A, B, C, D, E, F, that I want you to plot. And get in the habit of, excuse me, get in the habit of when you plot a point, put the letter next to it, because we're going to be doing some things with these transformations where we have the old image and then the new image, right? The old shape and then the new shape. And you have to distinguish which one's the old one, which is the new one by the endpoints. And you have to name the endpoints. So like, for instance, A is 3, 9. So let's go to, now what does that mean? Some of you are like, Mister, I forgot how this works. Okay. We have X and Y. That's how we plot a point. The first number is your X coordinate. X goes side to side. And Y is the second one, your Y coordinate, goes up and down. So this says I'm going to go 3 units positive and then to the left and right. So that means positive means I'm going to the right. And then 9 means I'm going 9 units up. Give me 1 second. All right, so if I say 3, 9, that means I go over here, go to the chart, and then this is your x-axis, and this is your y-axis, right? Your x-axis is the horizontal axis, and your y-axis is the vertical axis. And then you have numbers. They're basically 2 number lines going like this. They're basically 2 number lines, right? So if I'm going to do A is 3, 9, that means I'm going to start at the origin. I'm going to start here at 0, 0, and I'm going to go 3 on the X, and then 9 up. And then that's where my point is. And I'll label it A. Okay? That's how you plot a point. If you forgot, that's how you plot a point. You start at the origin, and that first number is how far along the x-axis you go. That second number is how far along the y-axis you go. That's it. Some of you are like, oh, that's right. Okay, I was doing this. I was going backwards, or I always flip them, mister. It's okay. So B is negative 5, 7. So let's go over here. So we go negative 5. So I go backwards 5, 2, 3, 4, 5. Then I go down 7 because it's negative 7. Nope, wait, it's positive 7, right? Let's go back. Oh, yeah, it's positive 7. See, sometimes we do that. We read it, and then our brain flips something or adds a negative. So it's negative 5, 7. So go negative 5. And then go up 7. And then we plot the point. And that's B. All right, C is 8, negative 3. So C is 8, negative 3. So that means I go 1, 2, 3, 4, 5, 6, 7, 8, and then down 3. 1, 2, 3. So it's right here. That's the point. And that's C. And I'm going to put them here. You don't have to put this, right? I'm just going to put the 3, 9, negative 5, 7. You don't have to put the actual coordinates. I'm just doing that for you guys. Excuse me. I'm sorry. Hold on. Let me get some water. Alrighty. So what I want you to do is this part. I'm just adding this part just for you guys, just for demonstration purposes. All right, let's look at D. D is -5, -6. So that means I'm going to go backwards. I'm going to go -5 again like I did before, but this time on the Y coordinate, I'm going down 6. 1, 2, 3, 4, 5, 6. And so that's D. Excuse me. Sorry about that. So that's -5, -6. And E is 7, 0. Now, E and F, if you notice, they both have a zeros. And I see this all the time, even with kids, even with adults who know how to plot, they get this backwards. 7, 0. That means the X side to side goes forward 7, but I don't go up or down. That's what this Y coordinate says. I don't go up or down. I go up or down 0. Okay, so if I'm doing E, I go 7, 0. That means I go to 7 and I stop. Okay, that's 7, 0. I go 7 on the x-axis and I don't go up or down. I go 0 units up. And then F, our last point, I have 0, 2. That means this is my x coordinate, which is 0. That means I don't go side to side. I go 0 side to side, and then I go up 2. So it's over here. 0 side to side and just up 2. And there's F, 0, 2. All right, are there any questions? Any questions at all? And remember, if you're afraid to ask questions, I'm not going to say what I used to say. I always used to say, don't be afraid, ask questions. But you know what? What did we learn these last 2 weeks? That's not a proper way to deal with fear. The proper way to deal with fear is not to say, stop it and don't have it. The proper way to deal with fear is accept it. So if you're afraid to ask questions, you're okay to have those feelings. Okay? And I've been making this mistake for years. It kind of sucks that people invalidate your feelings. They're like, Mister, this is how I feel. I'm afraid. Okay, have that fear. But what do we do with that fear? Right? This is what we learned last week. What do we do with this fear? Some of you put that in your warm-up yesterday. What do we do with this? We dance with the fear, right? We get the fear, we get that lizard brain, and we dance with it. We accept it. We're like, okay, I'm afraid of this. I'm afraid to ask questions because I don't want to look dumb. It's all about how I look. And there's all these myriad of reasons you may have to not want to be afraid to ask questions. So I'm not going to tell you to not be afraid. Go ahead and be afraid, but dance with that fear. And when you dance with that fear, you lead the dance, right? You still have that fear, but you lead the dance, meaning take a little chance. Take a little chance. So ask me a little question. Send me a little direct message and then see how it goes. Or send it to Miss Torres or Miss Rivas. Send them a little question. And then see how that happens with your dance with fear, right? It's a little challenging dancing with that fear because you don't want to put yourself out there. But do something little. So that's how you deal with your fears. You go ahead and embrace it, accept it, dance with it, and then take a little chance. And then next time take a little bit of a bigger chance. And then a little bit and then pretty soon you'll be dancing with that fear, but you're taking over and you're leading the dance. Right? But that fear might still be there, right? Like I told you, performers, all your favorite artists and performers, they have a bunch of butterflies before they perform. They still have that fear, but they go out there and they do it. All right. Are there no questions? Was this easy? Or did it at least, if it wasn't easy, did it at least rekindle some of your memories? Like, oh, okay, I know how to do that now. Okay. So before we do that, I want to show you what we're doing now. So when you go to your Schoology, you'll look and you'll see I'm only going to make one folder for each week now. I used to make 4 folders for each week, and some of you were saying, Mister, that was too many folders. So I'm just going to put the stuff in the folders. So I have week 1, week 2. They were just videos, the whole jungle tiger, lizard brain, growth mindset, dance with fear stuff. If you want to go back and look at that, you can. But week 3, that's where we're here, January 25th through 29th. Here's what I have. So now I have notes separated from your homework, okay? Because some of you asked that. You're like, Mister, you gave us a packet, and the packet had everything, and it was hard to find stuff, and then How do I turn it in? All that stuff. So I separated them. Okay. Your notes. So right here, translations, notes. That's just the notes. The homework will not be there. Now the homework, you click on the homework. Now I also, because some of you like Cami, now you can't see it here. When you click translations notes, you'll see the PDF. And if you're doing, if you're on Google Chrome, you will see Cami right here, open with Cami. You don't see it here because I have Safari, but you will see open with Cami. So now you can write on your notes with Cami and save it in your Google Drive. You don't have to turn in your notes. I know it has a due date there. Like, Mister, it has a due date. Yeah, don't worry about that because this is just notes. You're not turning in notes, but you are turning in homework. So when you go over here to homework, you'll see, you should see, if it's Google Chrome, you should see open with Cami. You could do your homework. I already had a couple people turn in their homeworks already. Good job. That means you know what translations are and you looked at it. So when I look at homework, there were 3 of you that turned in your homework. 3 of you have turned in your homework. And 2 of you missed the bottom. 2 of you looked at the bottom and saw 6, 5. There's 4 problems down here, but some of you only did the picture ones and you didn't read 7 and 8. 7 and 8 down here are 2 separate problems, 7 and 8, that have nothing to do with the picture above them. The picture is 5 and 6. So be careful. There's 8 problems on this, okay? But a couple of you did that, okay? But it's okay. Excuse me. Make sure you turn that in. I think it's due tomorrow. We're going to start our notes today. So here's what I'm going to give you a chance to do. Right now, I'd like you to take this out, the translation notes, however you do it. Some of you print them out. Some of you use Cami and write them on Cami and save them in your Google Drive. Or some of you use a handy dandy notebook, like I've told you. You may want to get a notebook like I've been talking to you about from the beginning, right? One of these notebooks that have graph paper in there, the ones that have graph paper in them, because it's really nice, especially since we're going to be doing a lot of things on the coordinate plane, have graph. But if you don't, some people are saying, Mister, I have line paper like a regular notebook. That's okay. You can still do a little graph on there, put the little tick marks on the X and Y axis. You can still do that. So let me show you. So you can still do this, right? You can still write a little graph or a big graph, and you don't have to put all the lines vertical and horizontal. You can just put little tick marks and then still plot your points like right there. Okay? So I'll give you a minute to get your notebook together because we are going to start taking notes. And at the beginning of the notes, I messed up. The beginning of the notes would say transformations. That's the big picture, right? There's 4 of them. And this should say translations, because that's the one we're focusing on. Okay, we will talk about what a transformation is in general, but we're going to focus on translations. Well, while you're doing that, I'm going to play you a little video that got stuck in a lot of students' heads when I did this last year. So in the beginning, you have to do a little reading. It explains what transformations are, and then they start singing a little song that may get stuck in your head.
Transforming that shape, there's a few options that are available to me, because I could rotate, turn it round, translate, shift it left, right, up or down, reflect, copy it across an axis of symmetry, rotate, turn it round, translate, shift it left, right, up or down, reflect, copy for you to cross an axis of symmetry. Hey.
All right, so that's the part of the video I want you to see. There's some more stuff there, but that's the part I wanted you to see. So now it's stuck in your head, right? Rotate, turn it around, translate. No? Last year I had kids coming in every morning singing that song. Mister, put the song on. Mister, put. So hopefully that happens again this year. I'm going to play this every day. I'm going to play that part so we can get it stuck in our heads. Now, those are only 3 of the 4 types of transformations, right? Those are the rigid ones. We're going to talk about what rigid motion is, okay? But those are the 3 rigid ones. We're going to start talking about translations today. But yeah, there's your video for the day. Hopefully it's stuck in your head. Rotate, turn it around, translate. No? Okay. So first, let's talk about transformations. That's the big picture. That's what this unit's about. No, we didn't have homework. Some people are saying we had homework. No, we didn't have homework. We didn't have any homework at all. There's homework there, but that's based on what we're doing right now. We haven't taken the notes yet. So no. People are okay, hold on. Time out. Don't worry. Sound the alarm. Don't. Some of you are very, very nervous right now. There was no homework due. There was classwork yesterday. But you did it in class. There was 2 slides, right? That was classwork. The homework that you just saw in Schoology, that's due tomorrow. That's based on translations. Haven't taught you that yet. Okay, so don't stress. I see a bunch of you sending me messages. Calm down. We did not have homework. A couple of people did do the homework because they were trying to get ahead. You don't have to get ahead. You can wait till we do the lesson. But yeah, don't stress. Some of you are stressing. Okay, these are the notes and the homeworks connected with these notes. Last year the students hated the song because they kept singing it. Yeah, they hated it, but it's one of those songs you hate, but it's still stuck in your head. Sometimes those are the best because it's like commercials, right? How many commercials have you memorized that you don't want in your brain? Because that's how music works. It sticks to your brain faster than almost anything else. All right, transformations. Transformations is the big unit. Okay, there are 4 types of transformations. Okay, we're going to focus on translations today, but let's talk about what a transformation is. Okay. So transformation, here we go, is an operation that maps. Basically, maps means moves. Right? So I'm going to get an image, or I'm going to get a figure, and I'm going to move it. There's different ways I can move it. Okay? So how can I do that? Well, we get the original figure. We get the original figure, and we call that, I know geometry does this, we call that the pre-image. So the original one is called the pre-image. And we move it into a new spot, and your new figure, or the new spot, is called the image. Okay, so we have a pre-image and an image. So if you look at the picture here, the pink triangle is the original. Well, this is the pre-image. And then the green one, the green triangle, is the moved triangle. That is the image, right? So the pre-image is the OG, the original. And then the image is the one that is the new figure, right? So this is the new figure. Okay. So the way we do this is, I don't know if you notice, they're both labeled A, B, C, right? But the new one, the new figure, has a little apostrophe next to the A, the B, and the C. Okay, so we say triangle ABC is the pre-image, the original one, and A apostrophe, B apostrophe, C apostrophe, triangle A apostrophe, but we don't call it apostrophe, right? This isn't English class. We call that prime. A prime, B prime, C prime is the image, the new figure. So that's why I want you to label your points. So that way, when you look at this, how do you know which one's the original one and which one's the new one? Well, the original one has the basic letters, A, B, C. So this is the original, triangle ABC, because they have no little dashes. We know this is the new one. We know that's the new one because it's triangle A prime, B prime, C prime. We have a little dash in there, meaning it's the new one. Right? It's new and improved. It's like 2.0. Right? So this moved. Okay. So these are transformations. Now, a transformation can change. Now listen to what these three things. We can change the position of something. Okay, so if I have, let's say this is an image. Okay, my little flashlight right here. I can change the position. That means I can change it, the position where it's at. I can change left to right, or I can change it up or down. I'm just changing the position. Next, I can change its orientation. What the heck is that? Okay, let me show you. So here's my flashlight. So I'm going to change the orientation. There you go. I'm changing the orientation, meaning I'm changing how it faces, right? Instead of, it can be upside down, it can be right side up, it can be sideways. This is changing the orientation. And the last thing is I can change the size of a figure. So here's the flashlight. Now it's bigger. Now it's smaller. Now it's bigger. Now it's smaller. I can change the size. Now, Mister, you're not actually changing the size, but the picture you see on the screen, it's actually getting bigger and smaller, right? I know the flashlight isn't literally getting bigger or smaller, but the picture you see on the screen is actually, it's looking bigger and smaller. So those are the three things I can do. So I'm going to give you a minute to copy this. So a transformation is an operation. It's a thing that maps. Maps just means moves an original figure to a new place. The original figure is called the pre-image. The new figure is called the image. And the original figure just has regular old letters, A, B, C, D, E. The new image, the new figure, the image, has primes on it. Those little apostrophes, A prime, B prime, C prime. And that's how you know when you look at a picture, that's how you know which one's the original and which one's the new one, because the original has basic letters. And the new one has those little primes, those little apostrophes on it. Okay. Give you a second to copy this down. Okay, any questions? This is just what transformations are. Okay, we're going to focus in on translations in a second, but this is just what transformations are, the big picture. And someone told me when I had it like this last period that it was too blurry. So if you need me to zoom in on anything, please let me know. Like, zoom in on that. And if you're asking, yes, I am recording the lessons again, and I will be putting them in the folder. Okay, so just look for the lesson videos in the folder. So they'll just be in week 3 folder. So if you want to go back and just look at any part of this, you can always go to the part that you missed or the part that you want to talk about again or listen to again. All right, so that's a transformation. Now let's talk about what I was saying, rigid motion. That video I showed you, the rotate, turn it around, translate. No? Okay. I thought some of you were going to unmute yourselves and start singing with me. Maybe you're singing along with me at home. And okay, maybe not. But those 3 that they showed in the video are the rigid motions. Because there's 4. 3 of them are rigid motions. 1 of them is not a rigid motion. What the heck's a rigid motion? Rigid motion means when a transformation preserves or keeps the size and shape of a figure. Okay, that's the definition. Rigid motion means when you move it, but you preserve, you keep the size and shape. You don't change the size and the shape. the thing that you're moving, the figure that you're moving, keeps the same size and shape. So when I move it from left to right, when I move the position, it stays the same size, stays the same shape. When I do a orientation move, it's still the same size and same shape. It's just facing different ways. Okay. When I do this, it's the same. It's the same. Okay. So those are all rigid motions. Now, what does that mean if we're thinking geometrically? If we're thinking geometrically and mathematically, then we think about, okay, this is a square. This is the original square. And then I move it over here, and this is the new square. These two squares are exactly the same, right? If I just move, here's my original, and I move it in a rigid motion, that means it stays the same shape, it stays the same size. That means these two squares are exactly the same. So if we think about exactly the same, that means congruent, mister. Very good. Very good. That means congruent. Yes. Good job. Good job. That means congruent. So what are we going to say? Let's put this in red. So that means all corresponding sides and angles of the pre-image and image are congruent. So that means if I have an original figure, okay, if I have an original figure and then I transform it or I move it in a rigid way, that means the same size and same shape. That means this and this, both the pre-image and the image, are congruent. All the sides are congruent. All the corresponding angles are congruent. Okay. So what are the three kinds of rigid motions? We have three of them. Translations are a rigid motion. Rotations are a rigid motion. And reflections are a rigid motion. Those three are rigid. That means the size and shape of the figure stays the same. The only one that doesn't is a dilation. It gets bigger and smaller. Okay, I'll give you a second to copy the definition and everything else for rigid motion. If you have any questions, please let me know in the chat. Please. But I'm afraid to ask. Okay, dance with that fear. Dance with that fear and take a little chance and ask a little question. In my 11th period, I have one student who asks a lot of questions, and I love it. And the rest of the class loves it because a lot of them, even at the end of the year, they're like, hey, thank you. They told him thank you because he asked questions that everyone else wants to ask but are afraid to. But I wish there was someone like that here in this class, one person who would ask questions that everyone wants to ask, but they don't. Like he asked today, what do you mean, mister? What do you mean by all this? What is pre-image? What is image? Why do they call it that? And the reason why they call it that, I don't know. One reason they might call it that is pre-image means before, and then the new image is after, pre and after, right? Or current. This was the before image. This is the current. This is the original. This is the new. So they call it pre-image and image. He also asked, why'd you put that part in red? Well, the blue part is the definition. Isn't that all we need for rigid motion? Why'd you put the red part? And that was a great question. I told him we put the red part because, yes, we have the definition of rigid motion, but now what does that mean for geometry and mathematics, right? What does it mean with the stuff we've been doing? Because I don't know if you remember, we were doing congruent triangles before with two exact triangles, congruent polygons, two exact polygons that are exactly the same. So if I'm going to do this type of movement, these rigid transformations, and the size and shape stay the same, that means the figures are exactly the same. The figures are congruent. All right. So that is basics of transformations. Now let's focus in on the one we want to talk about. Transformation number 1, translation. Oh, I know what that means, mister. I know what that means. Yes. What does that mean? It means if you know one language and you want to say it in a different language, you translate. That's why you get a translator. Very good. That is a definition of translation, but not ours. Not our definition. Our definition of translation, and I'll put it right here in this box. I'll put def for definition. The definition is to vertically and or, that means you can do both or just one, and or horizontally slide a figure. That means I get a figure. I get a figure and I slide it horizontally. That means it goes left to right. Or I slide it vertically. That means it goes up or down. That's it. That's all the translation is. Okay, so if you look at this picture right here, well, mister, let me copy it first. Okay, go ahead and copy it. There's your definition. To vertically and or horizontally slide a figure. That's the definition of translation. It's still blurry? Okay. It says, the definition of, it says to vertically and or horizontally slide a figure. Okay. I zoomed in as far as I can. Is that better? Or is it still blurry? Yeah, always let me know if it's blurry. Now, if stuff is blurry and you don't want to say anything, when you, I'm recording this in a different way. I'm not recording it using Zoom. I'm recording it using my, the broadcast software that I have, and I'm going to put it on YouTube. And so it's going to just should be much clearer. So if you can't see it right now because your internet or my internet or it's just very blurry, you could always go back to the video and look at the video. It's going to be a YouTube link. And you should be able to watch it in HD, and it should be a lot clearer. Okay. You might want to wait because I'm going to upload it right after class. You might want to wait a few minutes because it does take time for them to render it. Right? They put it up right away, then they have to render the HD version. It takes a few minutes. So yeah. So that's another thing I'm changing. I'm not recording on Zoom because actually the recordings were not that great. Some of you were telling me, Mister, the recordings are still blurry. So you can look at these recordings and they'll be much, much clearer. And you can go back and just slide. You can just slide the little, the video to where you want it and just copy really quick in case you missed something. You could always tell me during class too. You don't have to wait till the video comes out. You can tell me during class and I can zoom in on anything you want. Hopefully it's zoomed in good enough for you to see it. Okay. So what do I mean by this? So let's look at this picture. There's a picture under where it says translation. So can you tell which one is the original or pre-image and which one is the new image? I'll make one orange and make one green. Which one is the pre-image? Which one's the original? Anybody? The left one, yes, this is the original. How do you know this is the original? This is triangle ABC. You know it's the original because look at the letters. Look at the points. They're just regular old letters. A, B, C. And then if you look at this, you see it moved. It moved this way and this way. And that's how did it move? Let's see. This is the new image. So that's triangle ABC. This is the pre-image. This is the image, triangle A prime, B prime, C prime, right? This is the new one. And how did it move? How can we describe in words how it moved? Well, let's look at each point. What happened with each point? Let's look at point B because that's the one that's marked. It went over 1, 2, 3, 4, 5, 6. It went forward 6 units. 1, 2, 3, and then down 2 units. Let's see if C did that. 1, 2, 3, 4, 5, 6, and then down 3 units. 1, 2, 3. Yep. Now let's check for A. 1, 2, 3, 4, 5, 6 units, and then 1, 2, 3 units. Yep. So we can describe this translation as every point in the pre-image. Oh my God, I can't spell. Every point in the pre-image moved 6 points forward, right? Which means to the right. And 3, let's say units, not points. 3 units forward, and 6 units forward and 3 units down to move to the image, right? The new one. So is that true? Every point went 6 units forward and then 3 units down, right? And we saw that it happened with B, with C, and with A. So that's how we say it in words. How would we say it? How would we say it in mathematical way, in a shorter way? Because this is a lot of words, isn't it? That's a lot to say. There's an easier way to do this, and let me show you. Coordinate notation. It's called coordinate notation. And so what you do is you say X, Y, right? And then you put an arrow. This is basically saying you have a point X, Y, your original points, and then the arrow tells you this is what happened to move it. This is how you move it. X, we added 6 units. And then Y, what did we do? We went down, right? We went down 3 units. So this one said we moved 6 units forward, so that's plus 6. And then we moved 3 units down. So that means the Y subtracted 3. Down means minus. And there you go. This is the original point. This is saying how it moved. It's saying the original point moved. And how did it move? The X went up by 6 and all the Y's went down by 3. Does that make sense? So let me tell you in general how this works. So the plus 6 represents the horizontal shift, right, left to right. And the plus 3 represents the vertical shift, how it moved up or down. Okay, does that make sense? All right, I'm going to stop there because class is almost over. We will continue tomorrow. We will continue this tomorrow. If you have any questions, please let me know. I'll move my head out of the way. If you have any questions, let me know. We will continue this tomorrow. The homework's not due tonight. You can start the homework if you want to, but you don't have to. The homework is due tomorrow, but you can start looking at the homework. There's only 8 problems. And we will continue this tomorrow, guys. So everyone take care, and I'll see you all tomorrow.